Yes, sir.
You see in the previous class you are taken this. The question is find the nth derivative of sin square x plus 3 cos square 5x is there, that is already over. Now the second one is find the nth derivative of sin cube x into cos square x is there. That we will discuss from there onwards. You have to discuss it. Now you should see here sin cube x into cos square x is there. Okay, sin cube you don't have the formula directly because you have the formula for sin ax plus b or cos ax plus b. But here you see, use the formula sin 3a is equal to how you are writing sin 3a, 3 sin a minus 4 sin cube a. From that one, we find the value of sin cube x. You have to find out. Of course, instead of a, you have here x is there. Okay, first find sin cube x from this formula and you write here. Okay, then cos square x you can write as 1 plus cos 2x by 2 because 1 plus cos 2x is 2 cos square x. Again, this is also you write in this format. After you are writing that one, here in the denominator 4 is there, here also 2 is there. 1 by, you get 4 into 2 is 8, 1 by 8 you will get as the common you can write. Now, the remaining you have to simplify. If you simplify here, you will get 3 sin x plus 3 cos 4x into sin x minus sin 3x minus cos 4x into sin 3x. And here you see, you know the formula for the nth derivative of 3 sin x is there. You know the nth derivative for this. And here also sin 3x also you can write the nth derivative because already you have taken sin ax plus b nth derivative you are taken. Now, but you don't have the formula for the product. Cos 4x into sin x, you don't have the formula. And here also you don't have the formula here for this component. Now, you write 3 sin x minus sin 3x and then here 1 by it is as it is. Okay. Now here you see plus 3 into, already you know the formulas. Sin cos A into sin B equal to half sin A plus B minus sin A minus B. Compound angle formula here. If you apply that here, you can write cos x cos 4x into sin x you can write as this. Now similarly here the same formula you can apply cos A into sin B you can apply and you can write here sin A plus B minus sin A minus B, and here you are rewriting this component and this component as in terms of like this 1 by 2 of this 1 by 2 of this you are writing. Now you open the bracket 1 by 8 you write as it is, and here you see sin x 3 sin x is there. Okay, you open the bracket and you write the components here so that you get this 7 by 2 into sin x because here sin x is there. Here also we are getting minus 1 by 2 minus into minus is plus 1 by 2 sin x we are getting here, and here also we are getting 3 sin x. If you simplify we are getting this. Now you see why we are writing, you see already know the nth derivative of sin ax plus b, that is you are writing here you see sin ax plus b means you can add the nth derivative. Here also same format is there, here also same format you got. Therefore after simplifying y is equal to, actually y is how much is there, sin cube x into cos square x. You don't have the formula directly. That's why here you are applying sin 3x formula and here you are applying 1 plus cos 2x formula. Then you are simplifying and you are writing here this format. Now, for this you know the nth derivative. Already you know sin ax plus b nth derivative. You are already ax plus b or bx plus c or the same formula are taken there. You have to refer that. You see the previous classes there. There you got the formula for sin ax plus b. Now you see y is equal to this much. You have to find out, our aim is to find out the nth derivative. That means yn you have to find out. That is d to the power ny by dx to the power n you have to find out. Yn equal to, you have to write. Now up to this is the linearity property you can apply here and you can write 7 by 2 into d to the power n in the sense d to the power n in the sense nth derivative of sin x. And similarly linearity property will, if you apply here you will get the same here. Just you apply d to the power n on the components of that functions. Now here already you are taken the nth derivative is given by d to the power an sin ax is there. There you are written here you see just you are written sin n pi by 2 plus x is there, sin n pi by 2 plus x, sin n pi by 2 plus x, because here the value of a is equal to 1 is there. You compare this with sin ax plus b because you know the nth derivative of sin ax plus b, because a to the power n means here a is equal to 1, 1 to the power n is same, and here what is the function here, ax plus b means a is 1 and b is 0, x plus n pi by 2. Similarly here also you are adding here a is equal to how much, we have to compare this with sin ax plus b. Sin ax plus b means a is equal to 3, b is equal to 0, and here 3 to the power n, a to the power n. You have to know the form, then only you can understand this. Just you go through the previous classes and you refer the book so that you can get all the formulas. Okay, you have to be thorough with the formulas. Okay, here sin ax plus b formula you have to know. Then only you can add this. Yeah, everything is sin 3x ax plus b formula here you are applying. Now just I will explain for this and remaining as it is it will come. Now you see a is equal to 3, b equal to 0, and the a to the power n means you get here 3 to the power n sin n pi by 2 plus the value that was of the function here, what is again 3x is there, n pi by 2 plus x. Similarly here also you are adding 5x is there here. Okay, now okay, now you should see here sin 5x in the sense sin 5x in the sense the value of a is equal to 5 and b equal to 0. A to the power n means you get here 5 to the power n sin n pi by 2 plus that angle here ax plus b is there, b is 0, a is 5x, a is 5, therefore you are writing 5x. Similarly, then everything it follows as it is. Okay. Now I think you got the idea here. Okay, here you don't have the formula directly, that's why you're writing sin 3x formula by using this you're writing, and here 1 plus cos 2x equal to 2 cos square x, and then this was by using cos square x value you are writing here. Okay. Now here after you are writing, just to take, you have to simplify here sin 2x into sin 2x into cos 2x. The second one here itself you can leave. There is no need to take. If you want, you can take 1 by 2 common, and you can, it is not possible to write. Just you see 1 by 2 is there, 5 by 2 is there, 3 by 2, 1 by 2. You can take 1 by 2 as common, and you can add, or you can leave there itself. There is no problem with this. This is the value. Just you have to apply. You have to write the value of y in terms of finding, easy way in finding sin ax plus b formula. Then you have to apply the nth derivative. That is the main theme of this problem. Okay. Now the next one, y is equal to sin 2x cos 2x is there. Already you know sin into cos means you don't have the formula directly. Either you know the value nth derivative of sin ax plus b or cos bx plus b, but you don't know the formula for directly. That's why here you are using this formula, that is sin 2a equal to 2 sin a into cos a. Of course, here a is equal to here 2x you are taking here. A is equal to 2x. If you write, you get here sin 4x by 2. Again, sin 4x by 2, 1 by 2 into sin 4x you can write. And here you can take the nth derivative of this. Nth derivative of sin 4x you can write. Now, you can ask me the 1 by 2 is the multiple is there. Here multiply here 1 by 2 is there, that you can write outside. Only the function containing x you have to write here. You don't write here 1 by 2 is, if you write, so that is you can write outside. Okay, 1 by 2 you can write outside, don't write inside here. But because that is a constant, you can write outside. D to the 4n sin 4x is a is equal to how much here? You have already taken the previous case. The same formula here you are applying. A is equal to 4 and b equal to 0. Now a to the 4n means here 4 to the 4n sin n pi by 2 plus that angle 4x. Ax plus b is there actually 4x plus 0 you are getting here. That is equal to 4x. That's why you are writing here the same. Okay. Then y is equal to the next one, y is equal to sin 5x into cos x. Already you are taking the previous case. So see, there you are taken cos a into sin b. Likewise, you are taken here. Here sin a into cos b equal to this formula you have to use. Sin a equal to cos b. You can use this formula. What is the formula here? Just to see, sin a into cos b is equal to sin a into cos b, which is equal to, you can write sin a plus b minus plus sin a minus b you can write. Here sin a is equal to 5x here, b is equal to 3x, that's why you are writing here sin a plus b plus sin a minus b you are writing here. Now this is looks like the same formula here. Here also there is no formula directly here, that we are writing by using the formulas. You are writing sin a plus b plus sin a minus b, that is equal to 2 sin a into cos b. That's why that formula you are applying here and you are writing. Now the nth derivative you have to find out. Okay, here you may ask the question here, y is equal to, you are taken here, why you are not applying means you don't have the product, the nth derivative you don't know directly. That's why you are writing here why you are expressing in terms of sign of the two components, then you are applying the nth derivative. Now here also the same way. Here ax plus b means here sin ax plus b means a is equal to 8, b equal to 0. Then here you are adding 8 to the power n, because a is equal to 8 means a to the power n you are adding. This formula you have already taken in the previous classes. This is not quoting here. You see the previous classes, there you got this. Now a to the power n into sine n pi by 2 plus the angle you are writing. Okay. Actually here the value of d to the power n sine ax plus b is equal to a to the power n sine ax plus b plus n pi by 2. That is the formula you are getting. You got in the previous classes. So the same you are applying. So for this is also same you are adding. A equal to 2, then you are adding this. Okay. Now the next problem. Okay. Now the next problem. Y is equal to cos x into cos 5x into cos 7x. Already the same reason here. You don't have the formula for the nth derivative for this product. That's why you are adding here cos x into cos 7x into cos 5x. Okay. Now cos a into cos b you can write as half of cos a plus b minus cos plus cos a minus b you can write. Can I first you write cos x into you put the bracket replace these two into the bracket. Then here you apply this formula cos a into cos b equal to half of cos a plus b plus cos a minus b. Here a equal to 7x, b is equal to 5x. Therefore, cos a plus b means cos 12x plus a minus b means you get here 7x minus 5x is 2x, cos 12x plus cos 2x. Now, open the bracket and you write 1 by 2 outside so that you are getting. Again, here also, if you take directly here the nth derivative, you don't know the nth derivative for the product here also, you are getting two components. This is one component, this is another component. For individual, if you take the nth derivative, it is not there. Again, you apply the same formula here. Already taken cos A into cos B, the same formula you are applying here. And here you are adding. First, you rewrite the terms. Cos 12x into cos x, cos 2x into cos x. Now, you go for the same formula. Cos A into cos B equal to half of cos A plus B plus cos A minus B. The same formula you are applying here. Now, if you apply that, if you rearrange the first component, you get a 1 by 2 of this, you are getting 1 by 2 of this. Now open the bracket so that you will get here. Okay. Now here you see y is equal to you got here 1 by 2 into 1 by 2, 1 by 4 of this you are getting. Now for this you can apply the formula because you know the nth derivative of cos ax plus b. The same you can apply here. If you take 1 by 4 as common, you can apply the same cos ax plus b formula you can apply here. Nth derivative of cos ax plus b here also the same formula you can apply for all the four components here. Now here a is equal to how much? A is equal to 13, b equal to 0. Therefore a to the power n means you see in the previous case sin ax plus b are taken the same formula, but here the same they look like the same. Here sin means you are adding the angle cos of that angle plus n pi by 2 you are adding, then into a to the power n you are adding. Here a to the power n means the same way 13 to the power n cos n pi by 2 plus that angle 13x. Similar to the remaining thing you are adding because they are all looks like the formula cos x plus the same you are writing here. Okay, that is the case. Now, the nth derivative of the next problem here. Find the nth derivative of e to the power 3x into cos square x. E to the power 3x into cos square x. Now, here you see e to the power 3x we put as it is. Cos square x again 1 plus cos 2x is 2 cos square x. By using that here you can write cos square x, you can write like this. Now, here you see here you see 1 by 2 you can write outside. If you open the bracket here you are getting this. Already here e to the power 3x, already you know the nth derivative of e to the power mx. What is the value of nth derivative of e to the power mx? You see the previous class there you are taking the formula m to the power n e to the power mx, that is the nth derivative of e to the power mx. Now for the first component there is no problem here. The second one, already you have taken one more formula e to the power ax into cos bx. The same formula you can apply for the second one. Okay. This is e to the power mx. This is of the form e to the power ax into cos bx. E to the power ax into, of course you can write cos bx plus c also you can write e to the power ax into cos bx plus c formula you can apply here. Now here the same for both the components you have the formula. This is e to the power mx formula, e to the power ax into cos bx formula for the second component. Now you take the nth derivative. And you see, remember here for both components you are getting the nth derivative. That's why you are adding here yn. If it is not possible to get the derivatives, nth derivative, then you have to express in terms of the known one. Then you have to apply the nth derivative. Okay. Now the first one yn, y is you know here yn equal to 1 by 2 of so and so you are adding. Here already I am told to you e to the power mx is m to the power n. M to the power n means m is equal to 3. M to the power n e to the power 3x you are writing. The same you are writing e to the power mx, the nth derivative is m to the power n e to the power mx. Okay. Now plus here already you are taken the formula nth derivative of e to the power ax into cos bx plus c, or cos bx is given by r to the power n, r that is equal to a square plus b square to the power n by 2 into e to the power ax into cos n tan inverse of b by a plus bx. This is the formula of e to the power ax into cos bx. Of course, if bx plus c is there, just you have to take bx plus c in the bracket and you have to apply the same, and here you get bx plus c here extra. Okay, Both are one and the same here. Now here, I think you got the same here. First one is m to the power n e to the power mx. Now here you know that a is equal to how much here? You compare the second one, e to the power x into cos bx means a is equal to 3, b is equal to 2. You put it within this formula, you will get here what is that? A square means 3 square, b square means 4 square, 3 square is 9, 4 square is uh, sorry, 2 b equal to 2, 2 square is 4, and 3 square is 9, 9 plus 4 is 13, and here you run a 13 to the power n by 2 into e to the power ax means e to the power 3x cos n tan inverse of, what is the value of b here? The value of b is 2. The value of b is 2. 2 by 3 you can write. N tan inverse of b by a means 2 by 3 you are getting here plus the angle 2x you are writing. So this is the way you have to write out. Okay, this we have to know. The nth derivative of this bracket formula you have to know. A square plus b square to the power n by 2 e to the power ax into cos n cos of n tan inverse of b by a plus bx. This you have to know, then only you can write this. These formulas you have to make the list of the formulas and you apply the same so that you can get the idea. In the previous case here we have to know for to do the problem, here you have to know the nth derivative of e to the power mx and the nth derivative of e to the power ax into cos bx. Then only you can write this formula. Okay, the nth derivative means here, the next problem, y equal to sine hyperbolic 3x. Already you know hyperbolic functions means you get sine hyperbolic of that hyperbolic term, that is h we are getting here. Sine hyperbolic 3x into sine 3x. And here you see sine hyperbolic 3x. By using the definition of the hyperbolic function, you can write in terms of exponential. E to the power x minus e to the power minus x by 2 is equal to sine hyperbolic x. Replace x by 3x so that you will get this. Okay. Now into sine 3x is there. Into sine 3x. Now 1 by 2 you can take it as common. Now here sine 3x, open the bracket here and you write. Now you see for each component e to the power x into sine bx plus c, or e to the power x into sine bx you can write. And here also you can write e to the power x into sine bx. That means we can apply the previous water technique. This looks like the same formula we got in the formulas, the same you can apply here. Now you see here the individually you can write there, because you know the nth derivative of e to the power ax into sine bx, e to the power ax into sine bx. That's why you are writing here the same formula. You see here what you got 1 by 2 as it is. Here a is equal to 3. For this I am saying, okay, d to the power n into e to the power 3x into sine 3. For this I am saying a is equal to 3, b is equal to 3. Same, both are one and the same. A is equal to 3, b is equal to 3. Of course here c is not there, c is that is equal to 0. B sine bx plus c if you write there. Now a square plus b square formula, a square plus b square to the power n by 2 is there. A square means here with 3 square is 9, b square means here 3 square plus 3 square, that is equal to 9 plus 9, 18 to the power n you are getting here, 18 to the power n by 2 you are getting here. That's why you are writing here 3 root 2 to the power n. Okay, a square plus b square to the power n by 2. A square plus b square to the power n by 2. You will get here 18 to the power n by 2, that you can write as 3 to 2 to the power n. Now e to the power ax sine n tan inverse of b by a. N tan inverse of b by a. What is b here? B is 3, a is 1, 3 by 3 is 1. That's why you are writing n tan inverse of 1. Plus the same angle you have to write. Here also in the same way, here a is equal to minus 3, b is equal to 3. The same formula you are applying here. Now minus sign here. You got here a square means minus 3 whole square is 9, plus b square means 3 square 9, 9 plus 9 is 18, 18 to the power n by 2, that we can write as 3 root 2 to the power n into e to the power minus 3x into here e to the power, this for this we are applying here. R to the power n is over, e to the power ax is e to the power minus sine. Here we have to write sine n tan inverse of b by a. N tan inverse of, what is the value of b here? B is 3 here, a is minus 3. That means we are getting n tan inverse of minus 1 plus 3x. Minus 1 plus the angle you have to write. I think it is clear. Okay, here now we can take 3 root 2 to the power 3 root 2 to the power n, divide with 2 as common. Now the remaining you can write as it is. And here you see what is the value of tan inverse of 1. Here tan inverse of 1 means we are writing, how you can write tan 45 is 1. Therefore you can write tan inverse of tan pi by 4, that is equal to n pi by 4 we are writing here. Is it not? Have you got the idea or not? Tan inverse of tan x equal to x you are writing. That's why here tan inverse of 1 you can write as tan pi by 4. Tan inverse of tan pi by 4, that is equal to, yeah, pi by 4 you are getting here, into n is there, n pi by 5 pi by n pi by 4 plus 3x minus the same e to the power minus 3x into sine 3x. You are getting here the same here you are getting 3x is the 3x you are getting minus minus. Again here you can write tan inverse of minus 6 equal to minus tan inverse of x. You can write here the by applying that minus tan inverse of, again you are getting 1 tan inverse of 1 equal to, you see here you got n pi by 4. The same you are writing here. The same n pi by 4 means you are writing minus n pi by 4, because you see tan inverse of 1 equal to pi by 4. Because 1 is equal to 10 pi by 4, you can rewrite, and you can write tan inverse of 10 pi by 4 is pi by 4. I think you got the idea here. Okay, just you have to apply the nth derivative, and you, if it is common is there, you have to write outside, then the remaining thing you can put as it is. Now here cos hyperbolic 2x into sin square 2x. Now we express by using the definition. We express by using the definition. We express by using we express by using the definition. Okay. Now cos hyperbolic x. What is the how you can write by using the definition? E to the power x cos hyperbolic x. I am saying e to the power x plus e to the power minus x by 2 you are writing. You have to replace x by 2x here, so that you are getting this. Okay. Now sin square 2x is there. Sin square 2x means you can write 1 minus cos 2x, you can write as sin square 2x. So 1 minus cos 2x, you can write sin square x. Replace x by 2x, so that you are getting 1 minus cos 4x by 2. Now 1 by 2 into 1 by 2, you can write outside 1 by 4. If you open the bracket here, if you open the bracket, so that you can write here e to the power 2x e to the power 2x minus e to the power minus 2x. Just you open the bracket and write the components here, so that you are getting this. Now again you see, you have to verify whether the standard formula is there or not. E to the power mx formula. This is if you apply nth derivative e to the power mx, you can write as m to the power n e to the power mx. And here you see, already I've taken the previous case, you see e to the power ax into cos bx formula is there. Here also e to the power mx formula you can apply here. Here e to the power ax into cos bx plus here e to the power ax into cos bx formula you can apply here. Okay. Now y you can apply here. Okay. Now that means you can write the nth derivative yn equal to, you write here nth derivative, apply the linearity property and you write there. Okay. First one, you just observe here, e to the power 2x is there, that you can write as, how you can write e to the power mx, you are writing here m to the power n e to the power mx. What is the value of m here? M is 2. M is 2. M to the power n means 2 to the power n, and the e to the power mx means e to the power 2x we have to write. Similarly here also, m is equal to the power mx means m is equal to minus 2. M to the power n means minus 2 to the power n into e to the power minus 2x. Because e to the power mx you can write as e to the power mx e to the power minus 2x as it is. And then here already you know the formula. E to the power ax into cos bx formula is what? E to the power ax into cos bx formula is a square plus b square, a square plus b square to the power n by 2 e to the power 2x e to the power ax into cos n tan inverse of b by a plus that angle bx. You have to write there, cos that angle you have to write. Now here a square means how much you get? Only I will show for this. Okay, e to the power 2x into cos 4x is there. You apply that formula. First a square means here a is equal to 2 e to the power mx in, e to the power ax into cos bx. We have to compare this with that. A is equal to 2, b equal to 4. E to the power ax into cos bx formula. That we have to know. Then only we can add this. E to the a equal to 2, b equal to 4. A square means how much you will get? 2 square you are getting here. B square means 4 square is 16. Here 4 plus 16, that is equal to 20 you are getting. 20 to the power n by 2, that you can add as 2 root 5 to the power n. Okay. Now e to the power x as it is e to the power 2x cos, here you can write n tan inverse of b by a. What is the value of b here? B equal to 4, a equal to 2, b by a means 4 by 2, that is equal to 2. You are getting here n tan inverse of 2 plus that angle 4x you are writing as it is. I think you got here. This is how you are writing r to the power n, and that is equal to a square plus b square to the power n by 2 into e to the power 2x into cos n tan inverse of b by a plus that angle 4x you are writing here. Okay. Now the similarly the second one also you cannot as it is. Here you can see here e to the power ax into cos b, same formula you are using here. Here a is equal to minus 2, b is equal to 4. That is the difference. Here in the previous case a equal to 2 is there, but here you are getting a is equal to minus 2. Okay. Now apply the same formula. Here also you get a square means minus 2 square is 4, 4 square is 16. If you add those two, you get 20 to the power n by 2, that you can add 2 root 5 to the power n, and then e to the power minus 2x, e to the power ax, then cos n tan inverse of b by a. Tan inverse of b by a means here you see, here what you are getting here. minus here tan inverse of b by a means 4 by minus 2. You are getting tan inverse of minus 2. You are getting here tan inverse of minus 2. Here you are adding that tan inverse of minus 2. You can add as minus tan inverse of 2, and then the angle is 4x, is then 4x you are adding here. The same you are adding. Now here this is the required one. If you want, you can take 2 to the 4 2 root 5. Here you are getting here. Let it be no problem here. Here 2 to the 4n is there. Here 2 to the 4n. Here 2 to the 4n. Here also you can take 2 to the 4n as common, and you can add outside, or you can leave there itself. There is no problem here. Just you are applying, or you can leave that. Okay. Now the next one, e to the power 5x cos cube x. And you see the question is same for all. That is, you have to find out the nth derivative. Here also the same problem here. For the product you don't have the formula, but here e to the power 5x cos x is there. You can apply the formula. Is it not? The previous one what you have taken, that you can apply. But cube is there. That's why here you have to write cos 3x equal to 4 cos cube x minus 3 cos x. By using that, you can write cos cube x equal to, you can write this cos x plus 3 cos x by 4. Now you can write, open the bracket here and you write. Now if you open the bracket, how much you get? E to the power 5x into cos 3x, 1 by 4 of course is there, that is as a multiple. Now e to the power 5x into cos 3x plus e to the power 5x into cos x into 3 you are getting here. Okay, the same here. Actually you have to write one more step here. They are written directly here. Yn equal to 1 by 4 into, apply the linearity property, the first one second component you are getting. Well, you see already we have taken the formula. What is that? R to the power n equal to a square plus b square to the power n by 2 into e to the power ax into cos bx plus n tan inverse of b by a. That we have to write. Okay. Now a is equal to how much? Just you see here, a is equal to 5, b equal to 3 here. If you compare with e to the power ax into cos bx, a is equal to 5 is there, b equal to 2. A square plus b square means here you can write 5 square, and here you can write plus 3 square to the power n by 2 means 5 square is 25, 3 square is 9, 25 plus 9 that is equal to 34 to the power n by 2 e to the power 5x into, that is e to the power x means e to the power 5x into cos n tan inverse of b by a. What is the value of b here? B is 3, a is 5, n tan inverse of b by a plus that angle you are writing, plus that angle you are writing. Okay, similarly here the next one also you can use the same formula. A is equal to 5, here also equal to 5, but here b is equal to 1 is there. Okay, 5 square, a square plus b square means 5 square plus 1 square is equal to 26 to the power n by 2. The same for e to the power x means e to the power 5x into cos x plus, you have to write n tan inverse of b by a. You write here n tan inverse of b by a means here b equal to 1, 1 by 5, and then plus x you are writing. That is the case. Okay. Now I think you got the idea. After this we have discussed the nth derivative of sum of the values, nth derivative of sum of the values. And here you remember, you have to know the nth derivative of that formulas. Here you see in this problem, you have to know the nth derivative of e to the power x into cos bx to c. Here I am not given the formulas, but here you see the after the previous class, there you got the formula for this. Okay, before coming to the next class, you go through the formulas of what are taken in the previous classes.